All right, guys, this is the second part of this week's video presentation on fingerprinting. So we're going to cover different types of prints found at crime scenes, as well as different ways of developing latent prints. So let's go get into it. So different types of fingerprints found at crime scenes. We have three of them. We have latent prints, visible prints, and plastic prints. And they're pretty straightforward. So latent prints are the ones that you stereotypically think about when you're watching a crime show or a mystery. So these are the invisible fingerprints that you can't really see with your naked eye, but they're pretty much everywhere you touch. So it could be on a desk, it's all over your phone. So if you see all that grease on your phone is from you touching it. And it consists mainly of natural secretions from your skin. So you secrete a lot of water as well as oil that helps lubricate and protect your skin. Your skin knows how to take care of itself with oils and waters to keep it hydrated and so on. Next one, we have visible prints. Visible prints are clearly visible prints, as it might imply, left by colored materials on a person's hand. So, for example, a knife murderer is stabbing someone and they get the victim's blood all over their hands, and then they touch their blood and leave a bloody fingerprint on it. That's called a visible print. It can also be left behind by ink, grease, makeup, whatever pigmented substance where you don't require development to see it. Since we're talking about makeup, really cool fact is that a kiss, your lip print, is actually unique to you as well. So if you ever see a lipstick on the collar and then you can see a print, you can actually maybe try to use it as evidence. And then last but not least on this slide, we have plastic prints. So plastic prints is an impression left in a soft material. So the word plastic itself, you might relate to plastics as in the soft, bendy, moldable poly, uh, poly polymer materials used to make a lot of things like computers as well as packaging. But plastic in general, especially in science, means that it is malleable. It can change shape. Um, so if you're a plastic surgeon, you can change the shape of someone's body if they don't like it. You can change the shape of your nose, your hips, maybe your bosom. So any soft surface which can contort itself and leave a 3D impression, you can leave a plastic print. So this can be clay, it can be dust, it can be a piece of gum, or like starburst even. All right. So when we're talking about developing fingerprints, we want to get into the science of what's in a latent print. So latent fingerprints, since they're very hard to see with our naked eye, you need to develop them. And how to develop it depends on which component of the secretions the chemical will react with. So even though you can see on your screen that it's greasy, there might be a print there. That if you took a photo of it, it's going to look really, really, really crappy. It's not going to photograph well. So we want it to be easy to see, high contrast. So that's where development comes in. So most secretions come from these three glands. The first one, eccrine gland. So this is your stereotypical sweat gland right here. This is this little baby right here, and it's a gland that just opens up directly onto your skin, on your pores, and it secretes mostly water. And dissolved in the water are both inorganic as well as organic compounds. So your inorganic compounds and ions, these are things like salt that you taste in your skin. So your sweat's a little salty. That's why you drink Gatorade, to replace the salts. And there's going to be a little bit of organic compounds such as amino acids, lactic acids, ureas, and sugars. So macromolecules that are dissolved in your sweat. So this is the most important part for your fingerprints. So after we look at our eccrine glands, we have apocrine glands. So apocrine glands are a little weird. They create something called pheromones. So pheromones are chemical compounds that are similar to hormones, and they're used for signaling. And in pheromones, in particular, instead of signaling within your own body, that's what a hormone does. A pheromone helps two different organisms signal. So humans, there's the science behind it is debatable, but we know for other animals that they can smell each other's pheromones, not a distinct smell, so you couldn't describe how it smells. But once the other organism picks up the pheromones of another person, it allows the person, the different organisms, to assess whether or not that they are compatible, biologically compatible to reproduce. And then last but not least, we have sebaceous glands. So sebaceous glands are also known as oil glands. They secrete fatty or greasy substances. You might know it as sebum. And this is what's responsible for things like acne. So if you get this greasy pimple that's filled with yellow pus, that's thanks to your sebaceous glands. And these are open right up into the follicle of your hair. And it's we produce oil on our skin to lubricate our skin, to keep it all supple, and it's also to lubricate your hair. So your hair needs a little bit of grease or else it's too dry. All right, so developing latent prints. The method that you're going to use is going to depend on where your print is found and in the quality of the print. So some techniques are not good for certain surfaces. So the first and most obvious one we have is powders. This is what everyone knows. You might have done this in middle school. So powders are adhere to both watery and fatty deposits. So it's really good for a nice greasy print on like a smooth surface. So smooth surface, the powders want to stick to our to the fats as well as the waters. And then this is great for countertops, it's great for windows, metal surfaces, but terrible for things like clothing, paper, anything that's too porous or coarse. So you want to choose a color of powder that will contrast with the background. So this will be a white powder. So you can use something like talcum powder, which is baby powder, on our black desk, or you can use black powder on white surfaces. You can also use fluorescent colors to make it stand out a little more. And then with powders, not written down here, but very important to know, is that you need to take a photo of it after you develop it at the scene. And after you develop it, then you're going and you photograph it. You're going to lift the print. So you take a piece of tape, lay it on top of the print, so it picks up all the powder in its original place, and then you put it onto a piece of paper to be recorded and scanned later. All right. Next up, we have iodine. So the iodine method is best whenever you have paper. So iodine is a chemical compound. So the chemical compound is I2, and it is a nonpolar molecule, if you remember chemistry. So since it is nonpolar, like dissolves like, the fumes will react with the oils and fats within your sweat to produce a temporary yellow-brown reaction. So what essentially happens is that the iodine gas that is within your fume chamber, so you had to fume the object, and then this is great for things like paper. So paper is too coarse for you to powder it, because paper is very absorbent. It's going to suck right in, and then the powder is not going to really stick to it. So this is where iodine works really well, because it's not going to stick to the paper, because paper is very polar, and then iodine wants to stick to the greasy non-polar substances, so it's going to get dissolved into the fats within your secretions, the print, and then once it gets dissolved, it turns into a brown color. However, it's temporary, because once you just leave it out in the air, the iodine might, since it is non-polar, it's not going to really stick that well to the oil, and it's going to go back into the air and go away. So once you develop it, you see the color, you want to take a photograph of it for record keeping. And then we have three more methods. Next one, we have Ninhydrin. So Ninhydrin reacts with amino acids. So remember, eccrine glands release organic molecules, amino acids, the building blocks of proteins. So once again, this is great for things like paper, where powders can't stick to very well, but there might be trace amounts of amino acids from your eccrine glands. The Ninhydrin, whenever you spray it onto the surface and then you heat it up, is going to react with amino acids to turn it purple in color. And that's going to stick to it, so you don't have to necessarily take a photo of it, but it's good practice to take a photo of your prints to know what the context is. Next one, silver nitrate. So silver nitrate is a chemical that reacts with the chlorine to form silver chloride, a material which turns gray when exposed to light. So this method is a very old school method. We don't really use that too much anymore. But this is how basic photography works. So silver prints, anybody? Then last but not least, cyanoacrylate, aka super glue. So it's the same thing as super glue. You could do this at home, actually. So when you use super glue fumes, the you heat it up, it's going to create fumes, and the fumes want to react with the watery portion of your fingerprints. And whenever the super glue reacts with the water, it's going to create a hard white deposit on the surface. So if you want to do it at home, I like to use like a canning jar, so a ball mason jar, and then you put your object in. So this is great for small portable objects like knives, spoons, a gun, and you put it into the fuming chamber. So if you want to do this at home, you're going to be using your mason jar. So a gun wouldn't necessarily fit in your mason jar, and I would highly suggest against using your dad's gun. So you put the object into the fuming chamber, and then you put the cyanoacrylate. So in the labs, there's a device that heats it up, but you don't actually need to heat it up. So for me, I like to squeeze a tube of the super glue into a soda cap or something and leave it in the same container as the spoon, the object that you want to expose. You want to develop the prints, and then you screw on the lid, and then eventually the fumes in the super glue will start reacting with the water in the secretions, and eventually you're going to see a hard white deposit where that fingerprint was. And then you don't need any heat, just to wait like about 24 hours. The heat will speed it up. Highly discourage heating up. Please do not microwave that mason jar. And there you have it, how to develop prints.